Determination of the grain depth. Grain character and grain depth have a decisive influence on the appearance of a structure. In this regard, particular significance for tool planning and the selection of the respective structure must be attached to this factor. In order to avoid ejection difficulties such as stroke traces or scuffing. The establishment of the grain depth, particularly in critical tool areas with low minimum. The following rule of thumb applies. For each 1 degree of conicity, maximum 0.02 of a millimeter of grain depth can be ejected. These factors can affect this value. 1. Plastic's property, for example, flame resistant, glass fiber reinforced material and shrinkage. 2. Part design, wall thicknesses and the requirements for the dimensional tolerances. 3. Tool structure for cooling, sprue, slides and parting lines. 4. The injection molding process parameters. For example, in areas with expected core shrinkage, 3 times the standard conicity value for the ejection of the full grain depth may be necessary. If a reduction of the grain depth should be necessary in partial areas due to the tool design, the procedure must be agreed with the end user and must be taken into account accordingly when marking the components. Ejection difficulties such as stroke traces, scuffing, cannot be generally ruled out despite reduction of the grain depth, and additional optimization measures may become necessary. These shall be borne by the customer if not otherwise agreed. Hands-on explanation of product terms and features. Metal removal during graining increases the wall thickness of the plastic part, see graphic. Where necessary to ensure the dimensional accuracy of the part, customers should allow an appropriate graining allowance in the tool. Total metal removal, minimum. Draft angle for ejection, grain depth ejection direction. Example, leather structure with a minimum draft angle of 6 degrees and an averaged grain depth of 120 microns. As a rule of thumb, keep texture 0.03 inch away from parting lines and shut-off surfaces. Otherwise a zero parting line process must apply. What is a zero parting line? It is a technique to eliminate the appearance of matched insert parting lines. The insert is carefully hand-worked in the cavity, set in the molding position, and then textured in place, delivering a perfect parting line match. Zero parting lines are possible. In general, it is a repeated micro-welding and benching of the parting line to achieve a virtually invisible parting line. This process reduces the mold life, and it is a temporary costly fix for a molded part Class A surfaces. It can be a very costly maintenance plan for production tooling. The process for achieving zero parting line does not initially include the texture process. The tooling work for zero parting line is done by the texture source before the texture is applied. It requires collaboration among the toolmaker, its texturization provider and the OEM. The process should begin with a mold design review, as the design of the slide to cavity or core to cavity is critical to the success of this process. Here are recommendations and steps for matching a slide to a cavity in such a zero parting line process. A core or lifter could also be matched. 1. The slide must be bolted to the cavity throughout the texturing process. It is critical to address this cavity to slide fixture in the initial mold design. 2. The cavity and the slide must be made of the same type of steel, and the hardness level of each must be within 2 HRC of the other. 3. A trained zero parting line technician should assess the access to the seam area at tool design review to assure that the work in this area can take place unimpeded. 4. Once these bolt-on and access requirements are met, the zero parting line process may be achieved. The process includes peening and polishing. 5. The tool shop must deliver the best possible match between cavity and slides as per the OEM standard, 20 microns or 1/1000th of an inch maximum offset, with no flash. 6. Matching of the slide or a lifter in the cavity pocket must be securely bolted, without movement. 7. The match along the edge of the parting line must be absolute for a minimum of 1 mm from the parting line. 8. The last off sample parts from each cavity must be supplied to the texture house without requiring additional work after last off shots. These parts will set the expectation for the OEM as to how much of the seam will be hidden on the final parts. 9. The tool shop should properly bolt and securely lock the slide and lifter in the cavity pocket before shipping the mold to the texture house. 10. The texture house will touch up the cavity slide parting line match before applying the texture and through each etch stage, ensuring a perfect match. Condition. 11. After zero parting line work, molded samples are then produced in the tool without texture and again with texture. 12. Final gloss is applied with the slide insert bolted in place. Pregrain part evaluation documentation sign off. For this evaluation, the supplier must provide molded parts from an optimized production molding process. 3 parts from each cavity in black and or the darkest production colors are required for pregrain approval. Parts must come from the home line production facility. The supplier program manager, tool engineer, and or the quality engineer must arrange a meeting with the customer appearance approval engineer. The grain shop representative and the design release engineer must be involved in the pregrain part evaluation and mapping. The customer design release engineer must approve the dimensional report and fit and function of the molded parts before texturing the mold. The AAR engineer and the grain shop representative, they must sign 3 parts from each cavity. 1 signed part for the grain shop, 1 signed part for your record and 1 signed part for the appearance approval engineer. The grain shop will use the marked approved parts for the texturing the required surfaces. Parts will be signed off using the AAR form, and assigned one of 3 possible designations. Approved to texture. Supplier may immediately proceed to texture the tool. Correct and proceed. Supplier must correct all deficiencies noted and then proceed to texture the tool. Correct and resubmit. The supplier must retain the pregrain appearance approval report form and return it with any marked up pregrained parts when submitting. For post-grain appearance evaluation sign-off. Supplier must correct all the marked defects and resubmit parts for OK to grain approval. Post-grain texture part evaluation documentation sign-off. The appearance approval report, AAR, showing pregrain approval and all marked up, pregrained parts must be available for review with parts submitted for post-grain approval. Parts not providing a sufficient standard of appearance quality may be given direction for improvement, as noted on the appearance approval report. This same document must accompany submitted parts after appearance direction has been followed. Unless previously agreed, rejected parts must be included in the next approval review. The appearance approval engineer who reviews the post-grain appearance evaluation submissions will again sign the AAR form reflecting minimum appearance standard for the part, assuming full resolution of all issues. The parts approved for appearance will be identified with the minimum appearance standard. These parts must be retained by the supplier for their production and service life, and will be made available for review, upon request from the customer. Quality engineer whenever he needs it. The approved parts will be retained by the supplier quality team at the production plant as a master sample for a good quality production. Color evaluation documentation sign-off. In addition to surface appearance evaluation approval, all components that are in color, including black, require color evaluation approval. All parts submitted for color evaluation must have surface appearance AAR approval. Parts that require color evaluation approval. New parts in all program colors. Carryover parts in new colors. Material change or material source change. Submissions shall be produced from intended production tooling, process and manufacturing location. Submissions must include the master color plaque. Part suppliers must make an appointment with the customer color and harmony engineer. Parts approved for color PSW evaluation will be tagged with the minimum appearance standard label. These parts must be retained by the supplier for their production and service life, and will be made available for review, upon request from the customer. Quality engineer whenever he needs it. The approved parts will be retained by the supplier quality team at the production plant as a master sample for a good quality production. Color harmony review. Interior and exterior color harmony reviews will also be conducted to ensure overall vehicle harmony. Suppliers may be required to adjust, post-AAR sign-off, their component color at the discretion of the AAR engineer, based on color harmony team vehicle harmony review results. Minor color adjustments are allowable without the customer approval, provided formulas remain unchanged, except for minor ratio changes. These actions may be required to improve the overall color harmony of the vehicle. Color harmony reviews are conducted as both tabletop system reviews, as well as fully assembled environment reviews. Thank you for your time. My name is Amer Janineh, and please watch my other mold design videos.